Okay. Hello guys. Hello. Good evening. Good evening, everyone. Hello, Manohar. So I guess it started, right? The class has started, I guess. Okay. So yeah. So in today's one shot, the topic is motion in a straight line. Okay. So I'll tell you what we are going to cover in today's lecture. So first we will begin with the, as usual, distance and displacement, right? So we'll have a discussion on distance and displacement, and we'll cover all types of problems. Okay. Then we are going to move on to like the velocity discussion and speed discussion. Okay. Then we will move on to acceleration. And finally, we will cover the motion under gravity as well. Okay. Motion under gravity as well. And in case we have time, we will also cover graph questions. Okay. All types of graphical questions as well. These also we will take up in this lecture. Okay. So we will try to finish all this in 3 hours. Okay. So 3 hours is the approximate duration of the lecture. Basics. Yeah. So it will be based from basics itself. Okay. But we won't cover everything from scratch, right? Because in that case it won't be possible to finish in 3 hours, but I will teach as much as I can from basics itself. Okay. So we will begin. Let's start. Okay. All right. So we will start from discussing what is 1D motion. Okay, because this is the main part of the chapter, right? Motion in a straight line or 1D motion. So 1D motion is very simple. The definition. So throughout this chapter, we will only consider motion along one direction. Okay, which means, let's say this yellow line represents the x-axis. Okay, this yellow line, it represents the x-axis, and at some point we will consider the origin. Okay, so all the motion we are going to be studying in this chapter will only be along this one direction, which is along the x-axis. Okay, or it can be along only the y direction or only the z direction, into the page and out of the page. Okay, so all the motion we will be studying is going to be one directional motion. Okay, and one directional motion, in other words, you can also say it is a straight line motion. It is a straight line motion. So imagine a particle started from the origin, started moving along the x-axis and came to this point. This motion is motion in a straight line, right? Motion in a straight line. Okay, and this is, in other words, we also call this 1D motion, right? One dimensional motion. Okay, what is an example for a two-directional motion? Two dimensional. So that will be the next chapter, right? Next chapter, projectile motion. The example of that is a two-dimensional motion, 2D motion. So in projectile motion, motion happens in the xy plane, right? If this is the y direction, this is the x direction. We throw the ball something like this, and the motion looks something like this, right? So here motion is happening in the two dimensions. Both the x coordinate and the y coordinate of the particle keeps on changing with time, right? So this is an example of a 2D motion. This is an example of a 1D motion where only the x coordinate will change, okay, with time. As the particle moves along the x-axis, only the x coordinate will change. Okay, give me 1 minute. Just give me 1 minute. Okay. All right. Yes. So that is the definition of 1D motion. So 1D motion you can also use, I mean it's the same as motion in a straight line. Okay, these two are the same ideas itself. So now we will talk about these three quantities: distance, displacement and position vector. Okay, so first we will begin with position vector. So for defining what position vector is, we will take the xy plane once again. Okay, xy plane once again, and let's say this is the origin. Every position we will measure with respect to the origin. Okay, now let's say there is some particle on the xy plane which we want to mark, which we want to track. Okay, just a second. Okay, and this particle, let's give it the name of P. Now this particle, we want to mark down the position of this particle. Now in mathematics we use xy coordinates to do that, right? So we find the x coordinate of the particle and the y coordinate of the particle. So this is the x coordinate of the particle, this is the y coordinate of the particle, and we will say that the positions, the particle's coordinate is x comma y. So the particle is located at x comma y. Okay, now in physics right now we are going to use a different method to mark down the position. Okay, and that is known as the position vector. So what is the logic behind the position vector? It is simply a vector which connects the origin to this point P. Okay, so if you ask the origin where is the point P, so the origin will say it is over here, right? Now this vector connecting the origin to the point P, this is what we call the position vector of point P. Okay, we can use a symbol R for this. So R vector is the position vector. Okay, position vector of point P, Now in the last class we covered vectors, right? So if I know the x component of this, which is x, and the y component of R, which is y, I can write down R vector in terms of I cap and j cap, right? So if I know the x and y coordinates, I can also write the position vector as, so the x component of R is x, so it will be x along the I cap and y along the j cap. Okay, this vector is the position vector. So if I know the coordinates of the particle, I can write the position vector in this manner. Okay, now in case there is also the z coordinate in the question, right? Here we took a two-dimensional example, right, where a point is in the xy plane. In case it has a z coordinate also, like this, then the only difference is there will be a z in the position vector also, right? So like x1, y1, z1, so the position vector will be x1 I cap plus y1 j cap plus z1 k cap. That's the only difference. Okay, so this is just an alternate way to write down the position of the particle. So if the position of the particle is at x comma y, then the position vector we can represent it this way. Okay, now in this chapter, as I discussed, we will only cover 1D motion. Mainly we will cover 1D motion. So if this is the x-axis and this is the origin, and if we have any particle on this x-axis, okay, if I know the x coordinate of this particle, which means what is this distance OP, if I know this, I can write down the position vector. Okay, so the position vector will be, so it is at a distance of x in the I cap direction, so it will be x I cap. Okay, and this will be the position vector, this purple vector. Okay, so that is the idea of the position vector. In one dimension, it will only have one component, x I cap. In 2D, it will have two components, x and y, and in 3D it will have 3 components, right? Okay, so that is the position vector. Now there is a relationship between this and the displacement vector, so that we will study after covering the displacement. Okay. All right. Okay, so now next thing is distance, and distance most of you already understand the logic behind it, but I'll just summarize it once again. So consider any journey, okay, take initial point I, and you can choose any path to a final point F. Okay, this can be any path. This can be a curved path also, it does not have to be a straight line path. So in this curved path, okay, I'll choose an easier path so that it's easy to draw. So let me choose this path, okay, from initial point to final point. In this path, the actual length of the path covered, so that the path that you are seeing, the actual length. So if you measure the actual length of this path, that will be called as the distance, okay. So whatever is the distance of this path, if I call that as D, it will be basically the path length of this yellow path, okay. So distance in one line, you can also say it is simply the path length, okay. So whichever path you choose, the length of that path is called the distance. So here we have an example, okay, and in this example you're going from A to C, okay, you're going from A to C. Now there are two different paths shown here. In the first path, you go from A to B, pause, and from B to C. So in this path, what is the distance traveled? You go from A to B, it covers 3 meters, right? And then you go from B to C, it covers 4 meters. So in total, you cover 7 meters. So going from A to B to C, in total, you are covering a distance of 7 meters, right? But if you go from A directly to point C, then the distance covered is basically this length, which is 5 meters. In this case, the distance is 5 meters, right? So distance depends on which path you choose. If you choose another path, which is like this, it will be a different distance, okay? So that is it, that's the idea of the distance. It depends on which path you choose, and once you choose the path, it is simply the length of the path, okay? So if you go from A to B to C, it will be 7 meters. From A to C, it will be 5 meters, okay? Positional vector is also called z-axis. No. Position vector is something else, okay? Position vector is something else. Position vector is simply this vector connecting the origin of your system, okay, 0, 0 to the point that you want. So this point's called, position vector we want. So just connect it from O to this point P. This vector is the position vector, okay. Now you can, if this is in the xy plane, you can write it as xi cap plus yj cap, where x and y are the point P's coordinates, okay. So that is the idea. Z-axis is something else, okay. Z-axis is the third axis, right, in the xyz plane. So that is something different, okay. All right, good evening guys, good evening, hello. So where were we? Distance. So distance is done. So now let's extend this to displacement. So displacement also is straightforward. So start from some point I, and then you move along any path, reach some other point F. So we discuss what does it mean when we want the distance from I to F, right? It is simply the length of this yellow curve, right? But if I want the displacement, firstly understand the definition of displacement. So in this journey from I to F, the displacement vector is simply a vector joining the initial point to the final point, okay, that's it, okay, that is it. in your journey, if you want the displacement from this point I to this point F, I is the initial, F is the final. Displacement vector is simply an arrow connecting the initial point to the final point. Okay, always. Always. Even if it is motion in 1D, 2D or 3D, displacement vector is always like this. Okay. So, in our in this example, the starting point was A and the ending point was C, right? So, what will be displacement here? It is simply a line joining A to C, okay, which is basically the hypotenuse itself in this right triangle. So, I'll mark it like this, okay. Now, displacement is a vector, so I'll also put the arrow, okay. So, this is the displacement vector AC. If I ask you the magnitude of displacement, so we discussed the length of the vector is the magnitude of the vector, right? So, this will be magnitude of displacement, which I can also write it as S. So, for displacement, we usually use the symbol S, okay? Displacement, we will use the symbol S. So, here what is the magnitude of F? S. So, the length is 5 meters. So, magnitude of displacement is 5 meters, okay? So, displacement, when you want the displacement, only two things matter. Where is the initial point and where is the final point? Nothing else matters, right? Even if you choose this yellow path, this is the displacement. Even if you choose some other path like this, okay, then also this is the displacement. You can choose whatever path you can imagine from I to F. Displacement vector is going to be unique, okay. It's going to be simply this arrow from I to F. So, for displacement, you only need the initial point and the final point, okay. All right. We'll do some questions also in distance and displacement, so then it will be clear. So, here we have another example, okay. It's the same fact itself. We are starting from this point A and we are going to this point B. So, green path is path number 1 and the blue path is path number 2. In both these paths, initial point is A and final point is B. So, as I said, displacement is simply an arrow joining the starting to the ending. So, it will be simply this arrow, okay. So, if I ask you what is the displacement in the first path and what is the displacement in the second path, both will be the same, okay. They will both be equal. They will both be equal, okay, because initial and final point are the same. So, displacement does not depend on the path followed, okay. Whichever path you follow, it only depends on the starting and ending positions, okay. So, we'll do questions now. I guess we have yeah, before that let's also cover this fact, okay. So, there is one case in general. If I ask you compare distance and magnitude of displacement, they are not equal, okay. So, for example, in our old example from this point A to this point B, if I ask you the distance will be the length of this curve, right. The length of this curve will be the distance d, and the displacement will be, magnitude of displacement will be the length of this straight line, okay. Magnitude of displacement will be length of this straight line. So, as you can see, d is bigger than the distance, d is bigger than the displacement's magnitude, right. So, in general, you can say distance is bigger than displacement's magnitude, because displacement itself is the shortest path between 2 points, right. If you have 2 points A and B, the shortest path between A and B will be this straight line, okay. That is displacement only. So, any other path you draw, right, any other path you draw connecting A to B, the distance will be greater than that displacement, okay. So, in general, you can say distance is bigger than displacement, except in one case, okay, except in one case. And which case is that? So, if you have a one-dimensional motion along a straight line, okay, and the motion is happening without any change in direction, which means, let's say you're moving to the right, you keep moving along the right direction. Okay. So this is the starting point, this is the ending point. In this case, if you notice, the distance is basically the length of this purple line, right? So distance will be the length of this purple line, and so is the displacement. The displacement is also the length of this purple line. So this is the case when distance and displacement are equal. This is the only case in which distance and displacement's magnitude is equal. Okay. In every other case, you will find that distance is bigger than displacement. Okay. So yeah, this is something to keep in mind, guys. This can be asked. Okay. So if motion in a straight line is happening like this without a change in direction, okay, that means it needs to, if it is moving to the right, okay, then it needs to keep moving along the right. It cannot pause in between and start moving to the left. Okay. So without a change in direction, this is important. In this case, distance and displacement is equal. So in every other case, distance is greater than displacement. So if you want to combine these two facts, you can say distance is always greater or equal to displacement's magnitude. Okay. In general, it is greater than displacement, but in one case, it is equal to displacement. So that is what is written over here. Okay. So yeah, it's a simple fact itself. So now we can get to some question solving. Okay. So you guys can try this out. We have motion in a circular path happening. Okay. So this is like a quarter circle. This AB is basically 1/4 of a circular path, right? So if I am drawing a full circle, this AB, you can think of it like this. AB, you can think of it like this. It is basically 1/4 of this circular path. Okay. This is the journey from A to B. So there is some particle which starts its journey from here, moves along this circle to the point B. Okay. In this case, we have to calculate the distance and the displacement. Okay. So that is the question. Distance pi r by 2, displacement is √2r. Yeah, we will discuss the formula for displacement after this. Okay. In terms of the position vector, we will discuss it after this. But this question, you don't need any formula, you just need the geometry. And yeah, you got it correctly, right? Immortal, you got it. So the distance will be pi r by 2, displacement is √2r, right? So how did you get it? So distance is going to be the length of this circular arc, right? This quarter circle. So that you can just write it as, so there are two ways to write this. One way is, it's basically 1/4 of the total circumference, right? So here distance will be 1/4 of total circumference, which is pi r by 2, and displacement. Okay, displacement generally is a vector, guys. So when you write displacement, just include this mod also. This means magnitude of displacement, right? So magnitude of displacement, what is the displacement? If we move from A to B, displacement is a straight line connecting A to B, right? This straight line is the displacement. So what is the length of this displacement? We can use this right triangle, right? So if you apply Pythagoras theorem, this will be √2r in this right triangle AOB, right? So displacement's magnitude will be √2r. Okay, so this is the first case. Yes, distance is pi r by 2, and yeah, you guys are correct, right? Next is the semicircle. So tell me the answer for this. So now the journey is over a over half the circle. So what is the answer for this? Particle completes one full revolution with constant speed. Its distance traveled is non-zero. Displacement is 0. Can its average velocity also be non-zero? Average velocity is equal to displacement itself, right, Kirtan? Like average velocity, if you want, its definition is the displacement in the journey divided by the time interval in the journey, right? So if displacement comes out to be 0, then average velocity is also 0. Okay, displacement is 2r, distance is pi r. Yes. So here distance is half the circumference, right, of the full circle. So that will be pi r. That will be pi r. And displacement is going to be once again line connecting A to B, right? So this is simply the diameter of the circle, right? This line AB is the diameter of the circle. So the displacement will be r plus r, which is 2r. Its magnitude will be 2r. Okay, so correct. That is correct. Okay. Now the next one is a little bit more harder. So try this. Now it is not a semicircle or a quarter circle. It's a theta part of the circle, right? It's an arc which subtends theta angle at the center. Okay. So in this case, what will be distance and displacement? Try this also. Okay, so situation is something like this. We go from A to B along this arc of the circle. This angle is known to us, it is theta. Okay. Any idea, guys? What will be the answer in this case? So the distance will be, what is the distance in this case? Distance is always the path length, right? And here the path we are moving is along the arc of this circle, arc AB of the circle. So if I can get the length of this part, the arc of the circle, that will be my distance, right? That will be my distance. So there is a relation relating arc length of a circle to the radius and this angle theta. Okay. So if the arc length of the circle, if I say it is equal to S, okay, if I say the arc length is okay, if I say the arc length is S, can somebody tell me the relation between this arc length, radius and this angle theta? Distance is r theta, displacement is 2r sin theta by 2. Yes, perfect. Yes, that is correct. So the relation between this arc length of a circle, radius and theta, this is an important one, guys. So the arc length, you can write it as r radius into theta. So here you need to remember something, this theta is always substituted in radians, okay, not in degrees, okay. So like you can apply it in the quarter circle. So in the quarter circle, this arc subtends at 90 degree, right, at the center. Now 90 degree is pi by 2, radians. So if I want the arc length in this case, it will be r into theta, radius into angle in radians pi by 2, which is going to be pi r by 2. Same answer we got using this logic, right? So if you have another arc which, let's say, subtends 30 degree at the center, okay, then how will you write this length? In that case, the length will be r into theta, but theta you have to substitute as radians, okay. What is 30 degrees in radians? It is pi by 6. It is pi by 6, okay, pi r by 6. So here the thing is, in this case, s will be r theta, okay. So that will be my distance. So this is going to be r theta. So my distance is simply going to be r theta. That's the first thing. Now what about the displacement? For displacement, it's always the same. We connect the starting point to the ending point with a straight line. So the length of this blue line is the displacement. Okay, the length of this blue line is the displacement. So how do we find the displacement? So there is a trick to it, and not a trick, but we can use geometry here. So I'll draw a triangle. So in the other page, the triangle looked something like this, right? And this full angle was theta. These two side lengths were equal to r. So if you notice something, this is an isosceles triangle, right? This is r, this is r, this is the displacement, okay? This is the displacement. Now in isosceles triangles, we have a certain property. If you drop a perpendicular to this side, okay, to this side like this, this bisects the other side, okay, it bisects the other side, which means this length and this length, they are both equal, okay, these two lengths are both equal, and this is also the angle bisector, so it cuts this angle in half as well. So this is theta by 2 and this is also theta by 2. This theta angle also gets cut in half, okay. Now in this right triangle that you are seeing, the one with this r as the hypotenuse, okay, I can write down this length easily, okay. So if this r is the hypotenuse and this angle is theta by 2, remember from last class, the opposite side we can write it as r sine theta by 2, okay, and this length once again we can write it as r sine theta by 2. So what is the total length? Just add them up, right? So displacement will be, in this case, the displacement will be 2r sine theta by 2. 2r sine theta by 2, displacement's magnitude, okay. So in this triangle, in this motion, this side length is the displacement and this side length is actually 2r sine theta by 2, okay. This we had to prove using some geometry. So if it's 60 degrees, you will put 60 here, so it will be 2 into r into sine 30, right? So if it's 60 degrees, it will be r basically. So depending upon the angle theta, you can substitute the value here and then you can get the displacement, okay. All right. So this will be the answer, okay. So in the theta case, in the theta part of the journey, distance is r theta, displacement is 2r sine theta by 2, okay. So that is it. Now there is a, before this, we will also discuss a relation between displacement in position vector, okay. So we are bringing back our x-axis, this is the origin, and we have some particle p that is moving, okay. At the start I am saying its x coordinate is x1, okay, and after some time, let's say it moves to another point, it moves to another point where its new x coordinate is x2, okay. So here what is the displacement? If I ask you the displacement, it is simply the vector connecting the starting point to the ending point, right? So that vector will be, that vector is going to be this one. This blue vector is the displacement vector. Okay, I'm going to write it as S vector. So what is the length of this S? So S, if you want, all you have to do is from this length, which is x2, subtract this length, which is x1. So displacement, its magnitude will be x2 minus x1, as you can see, okay. And direction, as you can see, it is pointing in the right, okay. So if this is the x direction, unit vector will be I cap, right? So S vector, if you want, you can write it as the magnitude into I cap, right? Because I cap, because it is pointing along the right direction, right? Now this is nothing but change in the position, right? x2 minus x1 means change in the x coordinate. I can also write this as delta x, okay. So delta x I cap. So this is the relation between displacement vector and position vector. Displacement vector is simply change in the position vector. So in case it was 3-dimensional, then what will the displacement be? So the x direction will be x2 minus x1, and the y direction displacement will be y2 minus y1, and the z direction displacement will be z2 minus z1, okay. So there will be a k cap over there, or in short you can write this as delta r vector, right, which is r2 vector minus r1 vector. So displacement vector is simply the change in position vector, if you notice. So that is the relationship between displacement and position vector. In one dimension we only need the x coordinate, so it will be delta x vector. Okay, so to take a simple example, I am taking a 2D example, so it's easy to visualize. So x, y. So let's say we have some particle which started from, so somewhere on the x axis, okay, and over here I am saying the x coordinate is 15, okay, 15 meters along the x direction. This is the initial point A, and then it moved to another point which is, let's say, somewhere over here, 7 comma 10, okay, moved to this point. So it went from 15 comma 0 to 7 comma 10. The question is, what is the displacement vector? Okay, so you have to find the displacement vector. Okay, so give it a try, guys. So I'll just write the coordinate of A also. So A's coordinate is 15 comma 0, and it went from A to this point B, 7 comma 10. So what is the displacement vector? So you have to answer in I cap and j cap. Okay. So try this out, try this question. Try to get an answer. Class will be about 3 hours long, so it will go until 9, okay. So until 9 p.m. Okay, Hindu. So yeah, so any answers, guys? Any answers? So here we'll mark the position vectors. At the starting position of A is here, so mark down the position vector, it will be this one, right? So this is R1 vector, let's say, initial position vector. Finally, where is the position of the particle? It is at B, so mark that down. This is the final position vector, call it as R2 vector, okay? This is the final one. So we can write these two one by one. So R1 vector will be, so it is it only has an x component, right? 15. So it will be 15 I cap. What about R2 vector? R2 vector has two components, 7 I cap, 7 comma 10. So it will be 7 I cap plus 10 j cap. This is the position vector of B. Okay. What is displacement vector? Displacement vector is final position vector minus initial position vector. Okay, which I can also write it as delta R vector. So just write everything one by one. So it will be 7 I cap plus 10 j cap, and from this just subtract the initial position vector, which is 15 I cap. Then you will get the displacement. So subtract the I cap. 7 minus 15 is minus 8, right? So minus 8 I cap and plus 10 j cap. Minus 8 I cap plus 10 j cap. So yes, Manohar, that is correct. This will be the displacement vector. And in this diagram, how will it look like? It is this vector connecting the starting to the ending. Okay. This will be the displacement vector, which is also R2 vector minus R1 vector. Okay. So that is it. Displacement is change in position vector. And if we play in 1D only, it is only in the x direction. Okay, so displacement will be delta x itself. Okay, so now we can do some questions. Person walks 8 meters east and then 6 meters west. Okay, in this case you have to tell displacement and distance. So what will it be? So here east, just take it along the right. Okay. So first displacement is 8 meters to the east. Okay. And he reaches point B. And then from point B, he moves to the left by 6 meters, right? So I just don't want to mix it in this diagram itself. I'll draw that below. Okay. So then he moves to the left by 6 meters. Then what is the distance and displacement? Okay. It's finally at this point C. So what will be the answer, guys? What will be the answer? Any answers? So here distance, you just have to add these two lengths, right? So this is 8 meters. First path in journey from A to B, the distance covered is 8, and from B to C, the distance covered is 6. So you add them up. Okay, just add the lengths of the paths. So distance, you will get it as 40 meters. Then displacement is basically the arrow from the starting to the ending. So A is over here. Okay, C is over here. So this is the displacement length. Okay, this is the displacement length. So from the starting, which is point A, where is the particle finally? And the answer is, it is 8 minus 6, right? From this length, you have to subtract this length. So this will be 2 meters. So particle's displacement is 2 meters and it is along the east direction. It is along the right. So it is 2 meters in the east, right? Because displacement is a vector. So you also have to point out its direction. Okay. So yes, it will be option B. Option B is correct. Okay. All right. Now, next one. What is the answer in this case? Here the question is, someone runs a full lap of a 400-meter circular track. Okay. 400 meter. So this 400 meter is the length of the track. The 400 meter here is basically the circumference of the track. So this is the track in which the runner runs. The length of the circumference is 400 meters. So if he runs one full lap, which means he starts here and completes one circular motion, right? He runs one full circle. Then what is the distance and displacement is the question. So it's an easy one. Tell me guys, just comment it. It's an easy one. So distance will be basically, yeah, you guys try this. You guys tell me the answer. C. Is it C? Just recheck it. B. Yes, it is B option. Displacement is 0, right? Displacement's magnitude will be 0 because the starting point is over here. He covers the full circle and reaches back at the same point, right? So whenever we have a situation like this, when a particle starts at some point, continues in its journey and reaches to the same position back, right? He moves along this path and returns back to the original position. Initial and final point is the same. Then change in position is 0, right? He's at the same position at the end also. So in this case, displacement is 0. Okay, it's a 0 vector, but 0. Magnitude will be 0, right? So distance will be the length of the track because he runs 400 meter track. The distance will be 400 meters. Displacement would be 0 in this case. Okay. So B option, yes, that is the answer. Now try this one. Okay, this question you have to draw the diagram properly. So someone walks 5 meter east, 12 meter north and 5 meter west. Then what is the distance and displacement? Okay, try this. Try this question. So here, how will the diagram look like? 5 meters to the east. Okay, so in these questions, you can also draw the XY axis. Okay, this is the Y and this is the X. Okay, and he starts from the origin, let's say. He moves 5 meters to the east. East, I am saying it is along the X direction. So first displacement is 5 meters to the east. Okay. Then 12 meters north. Second displacement is 12 meters north. North, I am saying it is along the Y direction. And finally, 5 meters west. So this was itself 5 meters. So he is back at the Y axis. He touches the Y axis. This is 5 meters. So he started from here, ended up at this point, right? He ended up at this point. B. Yes, it is B. Good. So for distance, what will be the answer? Distance, you just add up these lengths. 5 plus 12 plus 5, which is 22, right? So distance is 22 meters. Now for displacement, you have to draw an arrow from the starting to where the particle is at the end. So just a second, it will be this arrow, right? This will be the displacement, and this length is the same as this length, right? So this will be 12 meters, and it is along the north direction. This is your displacement. So displacement is 12 meters along north direction. Okay, so that is option B. Okay, yeah, distance is the total path, and displacement will be that 12 meters north. For displacement, you just have to see where is it at the start and where it is at the end. Okay, this is the next one. So here we have a square of side A, square whose side length is A, and the particle starts from one corner and he stops at the opposite corner. Okay, he walks along the sides of a square. So this is one corner and he ends up at the opposite corner. Okay, finally, but he walks along the sides. Okay, so the path of the particle is something like this. The path in which he is walking is in this path. So here, what is the distance and displacement of the particle? That's a question. Okay, that is the question. So guys, what do you think? What is the answer? What is the answer here? Option A. Yes, option A is the answer. So distance will be the length of this path plus this path, right? So that will be A plus A. So distance will be 2A. Now displacement is the length of this line connecting the starting and the ending. So diagonal of a square is root 2 times A, right? Diagonal's length is root 2A. So that will be the displacement. So 2A is the distance covered, root 2A is the displacement. Okay. So A will be the answer. Yes, A is correct. So now this is the last question in distance and displacement. So try this. Athlete completes one revolution of a circular track of radius r in 40 seconds. Okay. So in the circular track, one full revolution, to run the track one full time, for one full revolution, the time taken is 40 seconds. So in 40 seconds, he completes one circular motion. So then the question is, in 2 minutes and 20 seconds, so the duration, if I use the symbol small t for this, 2 minutes is 120 seconds, 120 plus 20. So in 140 seconds, they're asking how much distance and displacement does he cover? Okay, in 140 seconds. So that is the question. So try this. So here you need to also find out how much revolutions does he make, right? So if he starts from this point A, In 40 seconds, he will cover one circle. In 80 seconds, he will cover two circles. In 120 seconds, he will cover three circles. So what is 140? It is 120 plus an additional 20, right? So in 120, 120 is 3 times 40. So he covers three circles. He covers three circles. 20 is half of 40, right? So in 40 seconds, if he covers a full circle, in 20 he will cover half a circle. Okay, so in 140, how many circles does he cover? 3.5 circles. So in 140 seconds, this person covers 3.5 full circles, 3.5 full circles. Okay, there is another way to find this. You can just do 140 divided by 40. That will also give you this answer itself. So if he covers 3.5 circles, okay, then what is the answer? Option C. Let's see. So if he covers 3.5 circles, one full circle, the distance is 2 pi r, right? In one full circle, the distance is 2 pi r. So in 3.5 full circles, the distance is 3.5 into 2 pi r. This will be 7 pi r. So this is the distance traveled by him. Now what will be the displacement? Displacement, you have to see where he is at the end. So after 3 circular motions, he will be back at A itself, right? On top of that, he is covering another half. So he will be over here at the diametrically opposite point, right? This is where he is at the end. So displacement is going to be simply r plus r 2r. This is the semicircle case, right? So displacement will be 2r. 7 pi r and 2r, yes, option B is the correct answer. Okay, option B is correct. All right. So is the question clear, guys? Here the main idea was you need to figure out how many circles does he complete. That's all. Now we can start with speed. Okay, now we can start with speed. So for speed, there are a few important points. So basically speed is the rate at which distance is covered with time, right? So in our earlier example where we had a particle moving in the x-axis, let's say he goes from a point A to a point B, and this is equal to delta x, some distance delta x. So if he goes from A to B, he can go from A to B super fast also or super slow also, right? He can cover this delta x distance in a long time or in a very short time. Okay, to quantify that we have the speed. Okay, so the speed you can say is basically how rapidly the distance is covered. Okay, in like simple terms you can define speed like this, or the true mathematical ways it is the rate. Okay, rate at which distance is covered with respect to time. So if it is high speed, then the delta x will be covered in a short time delta t, right? And if it is very slow speed, the delta x distance will be covered in a very long time. Then it is measured in units of kilometer per hour or meters per second, right? So you should know how to convert between these two. This is an important conversion. So if I want to convert kilometer per hour to meter per second, I just have to multiply with 5 by 18. So like 36 kilometer per hour, if I want to convert, I just have to multiply this with 5 by 18. Okay, and this factor will convert it into meter per second. So 18 cancels twice and it will be 10 meters per second. Okay, Okay, and if you want to do the reverse, just multiply with 18 by 5. Okay, dimension, this is just obvious, right? It is a meter per second, so a length over a time. So this will be the dimension. Now, when we talk about speed, we only care about the value and the unit, right? It is a scalar quantity. So, so there is no meaning for a negative speed. Okay, so speed can either be 0. This means the particle is at rest, its position won't change. Okay, so if we have a particle at rest and it is, let's say, at point A, it will always be at A. Okay, so 0 speed means particle is at rest, or it is positive speed. Okay, and positive speed means particle is moving. Okay, all right. Now, so now these are some categories of different motion. Uniform speed motion means speed is constant. Okay, so in uniform speed, if you take a fixed interval of time like 0 to 5 seconds, so in this 5 seconds the car traveled 20 meters, right? So if it is uniform speed, then I can say in the next 5 seconds, which is from 5 second to 10 second, it must cover the same 20 meters. Okay, in the next 5 seconds also it will cover the same 20 meters. So the distance covered in any second must be the same if it is uniform speed. Okay, uniform also means constant. This also means constant speed. So if the constant speed of a car, let's say it is equal to 20 meters per second, this means it covers 20 meters every second. Okay, so in between 0 and 1 second, it covers 20 meters. From 1 second to the next second, again it covers 20 meters, and so on. This is the definition of uniform or constant speed. Okay, the distance it covers every second is the same. Now, non-uniform speed is basically the counter to that, the opposite to that. Like anything, it can cover any distance in a fixed interval of time. So in the first 5 it is covering 20, and in the next 5 it is covering 40, in the next 5 it is covering 10. So it's non-uniform, right? Non-uniform speed means the speed keeps changing from point to point. Okay, then so now we'll discuss what average speed is. Okay. All right, so average speed. So what does average speed mean? So firstly, you have to once again consider a journey, okay, from some starting point A to an ending point B. Okay, now the average speed of this journey is defined as what if the distance traveled from A to B, if the distance covered from here to here, if that distance is equal to d, the average speed. So the way to denote it, V is the symbol used for speed, and just use 2 brackets like this. Okay, the brackets stand for average. So average speed is nothing but the distance traveled in the journey divided by the time taken in the journey. Okay, that's all. That's your average speed. So like to take an example, let's say we have some path, okay, like this, and it is given that the distance covered in this journey, from A to B, that distance is given as 100 kilometers, and the time duration of this journey was 10 hours. Okay, then the thing is the average speed, once again, its definition is the distance covered in the journey divided by the time taken. Okay, and that will give you the answer as 10 kilometers per hour. Okay, now this does not mean the car was traveling at 10 kilometers per hour everywhere. Okay, that is not what average speed of 10 means. The car can have any velocity, like here it can have 30, it might be moving with 30 kmph, let's say from A to this point, and from this point C to D, let's say it was moving with 10 kilometers per hour, okay, and from D to B it was moving at some 15 kilometers per hour. Okay, the car can move in like infinitely many ways, but average velocity or average speed cannot tell us about what is the speed at any moment. Okay, so if I ask you what is the speed at this point D, average speed cannot tell us about that, right? That is known as the instantaneous speed, and we'll discuss that, how that is calculated. But average speed is basically, if you get the answer as 10 kilometer per hour, what this means is, if you take the same journey, okay, if you take the same journey, okay, and which is like 100 kilometers long, right, and you want to finish this journey in 10 hours, what is that constant speed with which you have to move to make it possible? That is your average speed, okay, and the answer to that is, if you move at 10 kmph throughout this path, okay, if you move at 10 kilometers per hour throughout this path, you will reach your destination in 10 hours. But that does not mean the car was actually moving with 10 everywhere. Okay, so that is something to keep in mind. So that is your average velocity, average speed. And now there are some questions in which calculation of average speed is asked. Okay, so this is the first one. So a particle moves for 20 seconds, such that for the first 10 seconds it moves with a speed of 36 kmph, and in the next 10 seconds it moves with 54 kmph. Okay, so 36 kmph is basically, if you multiply with 5 by 18, 10 meters per second, and 54 kmph is what will this be? 16, right? So a 3s are 15, sorry, 15 meters per second. Okay, 18 times 3 is, yeah, so 3 into 5, 15, yeah. So I converted these speeds into meter per second. Now in the first 10 seconds it moves with 10 meter per second, and in the next 10 seconds it moves with 15 meters per second. So you have to find the average speed. Okay, so let's divide it into two parts. In the first 10 seconds of the motion, the speed was 10 meters per second, and in the next 10 seconds of the motion, the speed was 15 meters per second. Okay, so what is the average speed for the whole journey from A to B? So what is the answer? So for average speed, you just have to find the distance traveled in the journey upon the time duration of the journey, right? So the distance will be, so from A to this middle point, right, this intermediate point, what will this distance be? Here we are traveling with constant speed, right? From A to C, speed is constant. So you can write distance as speed into time, 10 into 10, 100 meters. And from here to here also, speed is constant, it is 15. So use speed into time. So this will be 150 meters. Okay. So the total distance traveled is 250. So the distance traveled in the journey is 250 meters. And the total time duration of the journey is 20 seconds. The answer is 12.5 meters per second. Okay. 12.5 meters per second. So that is how you do it. So basically you need to find out what is the total distance in the journey and divide it with the total time. Okay, let's try another one. So this is the next one. A train travels from a city A to a city B with a constant speed of 10 and returns to city A with a constant speed of 20. So city A to city B. So in the first half of the journey, he goes from A to B, okay, and the second half of the journey he comes back from B to A. So from A to B, his constant speed was 10 meters per second, and from B to C, the speed is 20 meters per second. Okay, then the question is, what is the average speed? Okay, so in the first half and in the second half, the distance is the same, right? Distance is basically the distance between A and B. So I'm just calling it as D, right? So what is the average speed? Average speed is, for this whole journey, what is the total distance traveled? So in going from A to B, the distance traveled is D. In coming back also, the distance traveled is D. So total distance is 2D, right? This is the total distance. Then we divide with the total time duration, right? How do we find time? So the relation is distance equals speed into time if speed is constant. If speed is constant, right? So what is time? Time is distance divided by speed. So for going from A to B, the time is D divided by 10. So for the first half of the journey, the time is D by 10. And for the next half, in coming back from B to A, the time taken is D by 20. So now we just have to solve this. This D cancels out. So I guess this will be 2 into, if you make this 20, it will be 3 by 20. So 20 goes to the numerator, and in the denominator you will have a 3. So 40 by 3 is the answer, and the unit will be meters per second. 40 by 3 meters per second. Okay, 40 by 3 will be the answer. So these classes are for NEET exam. Okay, these are mainly for NEET exam only. But for JEE also the theory is the same, right? For JEE the main difference is you just have to solve some better questions. Yes, 13.33, that will be the answer. Okay, so that was this type. Then we have one more. Okay, so here what is the question? A particle covers first 1/3 of the total distance with 10 and the remaining with a speed of 20. Try to get the answer for this, guys. So there is some journey from an initial location to a final location. The 1/3 of the first total distance. Okay, so if this distance is in total D, 1/3 of this, in this D by 3 part, the speed is 10. Okay, the speed here is 10, and in the remaining 2 by 3 D distance, the remaining 2 by 3 distance, the speed is 20. Here the speed is 20 meters per second. So we have to find the average speed. Okay, try to get the answer. $15. Yeah, so here this is similar to the last one itself. Total distance is D divided by time. Time do distance by speed. So D by 3 divided by 10. So D by 30, right? And here we have 2D by 3 divided by 20. That is also D by 30, right? That is also D by 30. So yes, it will be 15 meters per second. That will be the answer. Okay. 15 is correct. Great. Okay, so that was average speed. So now we will start discussion about velocity. And once we're done with velocity, we'll talk about the instantaneous speed and velocity. Okay. So velocity is not very different from speed. The main idea, at least. So the only difference is velocity is a vector quantity. So when we are describing a vector, if this is a block, let's say, and it has some speed, it is moving along the x direction, and in this direction its speed is, let's say, a constant 20 meters per second. So what does that mean? In the first second it covers 20, in the next second also it covers 20, and so on. Okay, but if I ask you the speed, you will only answer the 20 meter per second magnitude part, right? So the speed is simply 20 meters per second. But when I ask you the velocity, now it is a vector quantity that I am asking. So when you are mentioning a vector, you have to mention the magnitude of the vector and the direction. Okay, so take this direction as the x direction. So if you want to report the velocity vector, its magnitude is speed only. Okay, its magnitude part is basically the speed at which the block is moving, but you also need to include the directions information, I cap. So this I cap makes sure that this I cap tells us about the direction in which block is moving. So if you read V as 20 I cap, that means the block is moving along I cap. If it was 20 J cap, it means block is moving along the Y direction. And 20 K cap means it is coming towards the camera, right, out of the page. So that is the main difference. So velocity is a vector. So on top of the speed information, this is the speed information, you have to include the direction information as well. Okay. So everything else is the same. The unit is going to be the same unit as speed. Now velocity can be positive, negative or 0. Okay. Velocity vector can be positive, negative or 0. Like if this same block was moving to the left, right? If this same block example, if it is moving to the left with 20 meters per second, then now the new velocity vector will be 20 in the minus I cap, right? It is moving in the minus I cap direction, which is minus 20 I cap. So this is a negative vector, right? I mean, there is a negative sign there. So velocity vector can be negative as well. So that is all. That is all about. That is all in this slide. Then, so uniform velocity, here there is an important point. Okay, what does it mean by a constant velocity? So constant velocity is a vector, right? So if I say velocity is constant, so like in this block example, its speed is 20 meters per second. If I say its velocity is constant, then if velocity is constant, then that means two things. First is the magnitude or the speed is constant. Speed is constant. Okay, that means this 20 does not change with time. And number two is the direction is also the same. The direction is also the same always. Okay, the same, also the same always. So if this 20 meter per second I cap velocity is constant, it should be 20 the speed, and it should always be in the I cap direction. Okay, so if I take another vector, another velocity vector, which is 20 meter per second speed but in the j cap direction, this is 20 j cap. Okay, but this is 20 I cap. This is 20 I cap. 20 I cap is not equal to 20 j cap. Okay. For two vectors to be equal, there are two conditions always. Their magnitudes are equal, right? And the second condition is they are parallel. Okay. They are parallel vectors. So these two conditions need to be satisfied. Their direction and magnitude should always be the same. Okay. So that is it. That is the important point here. So constant velocity means if it's a 20 meter per second to the right, it is always 20 meter per second to the right. Okay. So that is constant velocity. Now non-uniform velocity or variable velocity is the opposite of that. If either the direction or the magnitude of velocity change, then it's a non-uniform velocity. Okay. So there is nothing much to talk about for this. So yeah, now we will discuss the next quantity, average velocity. So we discussed average speed for a journey. Now we'll discuss average velocity for a journey. So journey from point A to point B once again, and this journey takes some delta t time, let's say. So average velocity for this whole journey. So this is velocity vector and this means average. Okay. So average velocity vector equals the displacement in the journey divided by the time duration of the journey. Okay. So displacement, what was that? The vector connecting the starting point to the ending point. So this white vector is the displacement vector. So that displacement vector divided by the time taken in the journey, this is the average velocity. Now displacement vector, you can also write it as, from our previous discussions, change in position vector divided by change in time. Okay. So if this journey took delta t seconds, the displacement in that journey divided by the time, that is your average velocity. Now this average velocity is also a vector, right? This is of course a vector. Average velocity, this is a vector quantity. And what is the direction of the vector? So if you look at the right side, we have displacement vector, right? So average velocity's direction is the same as displacement vector's direction. So direction of average velocity vector is parallel, so this symbol stands for parallel, to displacement vector. Okay. So average velocity and displacement are parallel to each other. Yes. Applications, yeah. So questions are coming up. Okay, so this is the first one. A particle moves 20 meters in 2 seconds due east and then it moves 40 meters in 3 seconds due south. So always draw a diagram for these types of questions. Okay. So y axis and an x axis. So and the particle, let's say it starts from the origin, 20 meters due east. So draw that displacement. And 40 meters due south. Okay, so that second displacement also, just draw it. So this is 20 meters east displacement and this is 40 meters south displacement. First displacement happened in 2 seconds and this displacement happened in 3 seconds. Okay. Then first question is distance traveled. So distance traveled will be Distance traveled, what will be the distance traveled? You simply add up the total path, okay? 20 plus 40. So distance traveled will be 60. Distance traveled will be 60. What about displacement? Displacement is O is the starting point. This is where the particle is at the end. Connect these 2 points. Okay, connect these 2 points. Now let's just write the displacement vector. Okay, so say this is the x-axis, this is the y-axis. So you can write the displacement vector. So this vector, use triangle law. This is the displacement vector. So if you use triangle law, S vector is equal to this vector plus this vector, the purple vector plus the yellow vector. So purple vector is 20 I cap, okay. Yellow vector is 40 in the minus j cap, okay, 40 in the minus j cap. So minus 40 j cap. This is the displacement vector, and if you want the magnitude, it will be root of x component square plus the y component square. Okay, so take the 10 square outside, so that will come outside, and inside we'll have so you can also take the 2 square outside, so that will come out to be 2 outside, and inside we have 1 plus 4, right? So root 5. So this is 20 root 5. What are the units? Meters. 20 root 5 meters. So the length is 20 root 5. So this is the displacement, okay? Displacements, if you want only the magnitude, it will be 20 root 5 meters. Okay? 20 root 5, 12. Okay, great. So average speed. Now what is average speed? It's distance divided by time. Total distance in the journey is 60. Total time duration of the journey is 5 seconds. 60 divided by 5 is 12. 12 meters per second is the average speed. Now for average velocity, guys, you need to pay attention to the fact that it is a velocity it's a vector, right? So if it is a vector, so average velocity vector is equal to displacement vector divided by time, right? In the full journey. So displacement vector is 20I minus 40j. So that you will have to substitute here. 20I minus 40j. That you will have to substitute here and divide it with the total time of the journey, that is 5 seconds. So average velocity is 4I cap minus 40 by 5 is 8. So 8 j cap. Unit is meters per second. This is the average velocity vector. Now if you only need the magnitude, okay, so look at this. This is average velocity vector. So if you want the magnitude, I will put 2 symbols like this. Okay, this means magnitude of this thing inside, which is the average velocity vector. So this you can write it as, so what is the magnitude of this vector? Root of 4 square plus 8 square, right? What is this? 80? Root 80. This is the magnitude. Okay. So this you can also write it as, this is 16 into 5, right? So 4 root 5. 4 root 5 meters per second. Okay, this will be the magnitude. Okay, so if you only want the magnitude, you can divide magnitude of displacement divided by time. So magnitude of displacement is 20 root 5. Just divide with 5. Okay, that will give you magnitude of average velocity. So this is magnitude of average velocity. Okay. All right. Okay. So that was this question. Now, so we'll have another similar question. Okay. Here, person moves north with a uniform speed of 17 meters per second and covers 16 meters. Okay, similar question itself. So he moves north with a speed of 17 meters per second and covers 16 meter distance. 16 meter distance, 17 meters per second. After this, he moves towards the east and covers 8 meters. Moves to the east, covering 8 meters. Okay, and then he covers 10 meters with the same speed in the south. So then he moves to the south, 10 meters. Now, this is 16, right? 10 will be lower than that, something like this. This is the 10 meter displacement along the south with the same speed. Okay, so in all the entire journey, the speed is the same. Speed is 17 itself. Okay, so in the full journey, the speed is 17 itself. Okay, speed is 17 itself. So the first question is, what is distance? Distance is simply the path length, the total path length. So this is the starting point, this is the ending point. So distance will be 16 plus 8 plus 10, right? So that will be 34. 34 meters is the distance. Then displacement. Displacement, if it is simply asked, we will calculate the vector, right? So how do we calculate displacement vector? It's going to be this one. This is your displacement vector. Break it down into the x and y. So this is the x component of the displacement. I'll use dotted lines. This is the x component. This is the y component. So what are these two lengths? The x component, this length is 8 meters, and the y component, what is this length? It is 16 and you subtract 10. 16 minus 10 is 6. This is 6 meters. So in this vector, the x component is 8, y component is 6. So displacement vector will be 8 in the I cap direction and 6 in the j cap direction. Okay. Now this is the 6, 8, 10 right triangle. So this yellow side length is equal to 10 meters. So if magnitude is asked, it will be 10 meters. Okay. Now finally, what is the average velocity? Average velocity will be, you take the displacement vector and divide it with the total time. Okay, so displacement vector is 8i plus 6j. Total time, okay, so we covered a distance of 34 meters, right, in total. So we covered a total distance of 34 meters and 34, 10, 10. We covered a total distance of 34 meters and we did it with a speed of 17 meters per second. So what is the time going to be? Distance divided by speed, which is 2 seconds. Okay, so the journey was completed in 2 seconds. So displacement by time, if you do, so just divide this with 2, so that will be 4 I cap plus 3 j cap. Okay, so if you want just the magnitude of this thing, magnitude of average velocity, that is equal to 5, right? 4i plus 3j, its magnitude will be 5. This will be the average velocity. Okay. So any doubts in any of this calculation? Any doubts in any calculation? Yes, it will be 5. When to take vector? When to take vector? It's simple. So, well, generally speaking, displacement is a vector quantity, right? So we should always write it as I cap and j cap, meaning we should always write it in vector form only. Now, if they want the magnitude, then they should specifically ask the magnitude. So, what is the magnitude of displacement? Okay, that will be 10 meters. But if simply the displacement is asked, then we should always answer it in I cap and j cap. Okay, or like they will also give hints in the options. So, in like NEET exam, they will ask the displacement, and the 4 option will be a magnitude only, right? It will be 10 meters, 20 meters, 10 root 2, none. Like in this case, of course, they're asking the magnitude only, right? So that way also you will get the hint. Okay, but in general, if displacement is asked, it's a vector, right? So we should write it as a vector only. Okay. Yeah, but if you are not using the vector form, what you're finding is the magnitude only, right? So if you write the answer as 10, what you are writing is the magnitude of the vector, the magnitude of displacement. Okay. Yeah. So there are a lot of questions from average speed in NEET. So average speed, average velocity, these are also asked. Okay. Like I in my class lectures, I covered a lot of questions. Today's question, I don't think I brought NEET questions. Okay, let's see. But these are definitely asked. Okay, these are definitely asked. The next most commonly asked is the instantaneous speed and velocity part. Okay, so instantaneous is basically simple. The definition. So we are looking at a journey from some point O. Okay, starting from some point O. And this blue path is the the path of the particle or the object. Okay, so in this path, if I ask you what is the speed or the velocity at O, it will be v1 vector. Okay, if I ask you what is the speed at A, it will be v2 vector. Speed at B will be v3 or u3. Speed at C will be u4. Okay, so speed at a specific instant is called instantaneous speed. Okay, so let's say this is t equal to 0 at 0 seconds. The speed is v1. This is, let's say, at t equal to t1. The speed and velocity is v1. At t equal to t2, the speed and velocity is v3. And and let's say at t equal to t3, the speed and velocity is v4. Okay, the speed at any instant of time. That's what we call the instantaneous speed. Another important point is, let's say we follow this path from in a journey, okay, from A to B. In this path, if I want the direction of the velocity at some point, so let's say at this point, what you have to do is draw a tangent to the path. Okay, draw a tangent to the path. The velocity will be in this direction only. So I'm going to call this point as point 1. So here the velocity will be v1 vector, okay, and the speed at this point, the speed at this point will be the magnitude of the velocity vector, okay. So speed here at this point will be v1, speed will be v1, okay, and these are both the instantaneous speed at this point, okay. Then at a second location, let's say 2, here if you want the velocity, it will be in this direction along the tangent at this point, and let's say this is v2 vector. So the speed at this point is v2, okay, speed at this point is v2. So here the instantaneous velocity is v2 vector and the speed is v2. So that is basically it for instantaneous speed and velocity. Now here to find this we will need some differentiation, okay. So we'll discuss the logic for that, but we won't discuss differentiation in detail here. So we'll consider our simple one-dimensional motion, okay, and we have some particle over here and it is moving to the right. At this instant I am saying its velocity is v and the speed is v, okay, so it's moving to the right. So to find the instantaneous speed, if I want the instantaneous speed, I'll explain the logic, okay. What we do is we observe for a very small time interval, okay, and that very small time interval we give it the name of dt, okay. Okay, how it is defined in maths is infinitesimally small, infinite, okay, this is how it is defined in maths. I mean, this is what dt means in maths, which means it is a very small quantity, okay, as small as you can imagine. In this time duration, of course, this particle will move to the right by some distance, right? So I'm like exaggerating it, but let's say it moved by this much. So because this is a very small time, the distance it covers will also be very small. That distance I am calling it as dx, okay, that distance I am calling it as dx, x because motion is happening along the x direction, okay. Now the main logic is, even if this speed is changing with time, okay, for this small dt time, v can be approximately, which is the speed can be approximately considered as a constant, okay, considered as a constant. Even if the speed, like after 10 seconds it is something else, okay. So let's take some example. I am saying v is 10 meters per second, okay. This is not a constant speed motion, okay. So after 10 seconds speed can be 20, it doesn't matter. But for this dt time interval, for this very short time interval that we are studying this motion, I can consider v to be approximately constant, okay, because it doesn't have that much time to accelerate. So I can roughly consider it a constant. And in this case, if it is constant speed, I can write distance equals speed into time, right? Distance equals speed into time, the constant speed relation, right? Hence, I can get the instantaneous speed at this point as dx by dt, okay, dx by dt. So this is the instantaneous speed, this is the instantaneous speed, okay, at let's call this point as point P. So at P, okay, this is how we define instantaneous speed. Yes, we will have to do differentiation here. Hello Tausif, I'm good. I'm good. Yeah, so now this is where differentiation enters into the story, but like we can discuss the whole differentiation process here. But I'll just give a rough idea, okay? For some functions we can talk about it. We can actually do this question and study it, okay? So here the question is similar to this case. A particle is moving along a straight line along the x-axis. Then the distance x they have given, okay, as this function of time. So if you put t equal to 0, it is 10. If you put t equal to 1, it will be 10 plus 3, right? 13. So this particle is moving to the right, basically. So if this is the x-axis, take the origin here. At the start, t equal to 0, if you put, you will get 10 meters. So at t equal to 0, particle is at x equal to 10 meters. At t equal to 1 second, it will be 10 plus 6 minus 3, 13. At 1 second, at t equal to 1 second, the particle is at x equal to 13 meters. So this dot is moving to the right, right? So the question is, how long will the particle travel before coming to rest? It will start moving along the right. Okay. So they're asking when does it come to rest, you know. So what does rest mean? Speed equal to 0, right? When does the speed become equal to 0? And we are given x as a function of time. Now speed at any instant of time, the instantaneous speed, from now on all the speeds we will be discussing is the instantaneous speed itself, okay? So if I want the speed, I need to differentiate x with respect to time, okay? So this is in maths this is known as the derivative of x with respect to time. So there is a process to find dx by dt if x is given, okay? So how we do it is, so d by dt of, just put x instead of instead of x here, put this thing. So it will be 10 minus 60 plus, sorry, not plus, 10 plus 60 minus 3t square, okay? So we have to differentiate this. So this will be split into 3 terms, d by dt of a constant which is 10, then d by dt of 60, so that constant you can take it outside, into d by dt of t, and minus 3 is a constant, and d by dt of t square, okay? Will be split into 3 terms like this. The constant 6 you can take it out. Here the constant is minus 3, that also you can take it out of the differentiation. Okay, now there are some rules to this. Differentiation of a constant is 0, okay? Differentiation of the constant is 0. Here 10 is a constant, so that will be 0. Then if you want to differentiate a polynomial, right, over here, if you want to differentiate something like a t raised to n, this is a standard formula, okay? If you want to differentiate t raised to n, it is this power n will come in front, okay, and that you multiply with t raised to n minus 1, okay? So this power n, you put it in front and you reduce the power of n by 1. So if you want dt by dt, so here n is 1, right? So on the right hand side you will get the answer as 1, and if you want dt square by dt, so this 2 will come to the front and you reduce the power of t by 1, so the answer is 2t, okay? And if you want to do the derivative of t cube, it will be 3 into t square. 3 comes front and you reduce the power of t by 1. And how do you differentiate 4t raised to 5. So here this 4 is 4 constant can be taken outside, okay, and what is left is t raised to 5. How do you differentiate t raised to 5? The 5 comes front and you reduce the power of t by 1. So this in total will be 20 t raised to 4. Okay, so this is just a simple explanation of differentiation. There are more rules that exist, but here, I'm just not covering all the rules. Okay, here I just want to discuss the motion part. Okay, nt raised to n minus 1, yes, 20 t raised to 4, correct. Yeah, so what will this be? Here finally the velocity will be, or the speed will be, dt by dt is 1, so 6 minus derivative of t square is 2t. So 2 into 3, that will be a 6, so minus 60. Okay, 6 minus 60 is the velocity or the speed. Now what we need is, if you put different values of t, you will get different values of the speed. Okay, so at t equal to 0, if you put 0, you get 6 meters per second. So at the start, the speed is 6 meters per second. Okay, at 1 second, if you put, it is at rest. At 1 second, it is at rest. I mean, that is what we wanted also. When is the particle coming to rest? The answer is, it comes to rest at 1 second. Okay, after 1 second, particle comes to rest. Okay. And if you put 2 seconds, you will get a negative answer, right? At 2 seconds, you will get a negative answer. V is equal to 6 minus 12, which is minus 6. Okay, negative just means one thing. It means the particle is moving to the left now. Okay, it is moving to the left with 6 meters per second. If it is positive, it is moving along the positive x direction. Okay, that is what a negative answer means. Negative answer means it is moving to the negative x direction. Okay. Detail. So detail, the thing is, I will have to cover whole calculus here. So calculus usually, so here the extra part is the differentiation, right? So differentiation, this, if you guys want, I can take it in the next lecture. Okay, in the next lecture we can do basic maths. Okay, and in the basic maths part, I will cover differentiation as well. We can also cover trigonometry as well. So like today's lecture, I don't want to cover all the differentiation laws, okay, because this is motion in a straight line, right? So that's why I'm not covering it in detail. Okay, but don't worry, like this differentiation, we only have a few cases of this. Okay, rest of the lecture you will be able to follow even without differentiation. And differentiation, if you want, we can cover it in the next case, in the next lecture. Okay. All right. Integration also, yeah, sure. Then, yeah, so now we will begin with acceleration. So, yeah. So acceleration is basically when we try to change velocity vector, we need an acceleration. Okay, so right now we will only talk about the 1D case. Okay, the 1D case, one dimensional motion case. So 1D motion, let's say the block or the particle it is moving to the right. Okay, its velocity at some point it was along the x direction. So accelerated motion means this this velocity will increase or decrease. Okay, speed will increase or decrease. Now if it is an accelerated motion, which means speed increases with time, then acceleration will be in the direction of the velocity. Okay, in this case what happens is speed increases with time. Okay, speed increases with time. Speed increases with time. And the second case is there are only two possibilities. If it is 1D motion, the acceleration can either be in the direction of velocity, or it will be opposite to the direction of velocity. So in the second case, I am saying velocity is to the right, and if this is a decelerated motion, then acceleration will be to the left. Okay, acceleration to the left means the speed will go down with time. So speed decreases with time. In this case, speed decreases as time passes. Okay, in the second case, these two are the only possibilities other than a is equal to 0. If acceleration is 0, then speed is constant, right? The other cases where acceleration is perpendicular to velocity, this comes under 2D motion. Okay, that we will cover in the next part. So in 1D, these are the only two possibilities. Now let's just say in this first case, in the first example, let's look at the relationship between acceleration and velocity. So here also we will do a similar analysis to what we did in this slide, basically, right? How we wrote velocity as rate of change of position dx by dt. Here we will try to relate acceleration and velocity like that. Okay, so step 1 is observe for dt time. Okay, dt time duration, and in this dt time duration, say speed increased by, speed will also increase by only a small amount. Say speed increases by dv. Speed increases by dv. So observe for a dt time and say the speed increases by dv. Okay, then we define the acceleration at this moment as dv by dt. Okay, this is the definition of the acceleration. This is the definition of acceleration. So acceleration is defined as dv by dt in this case. So basically in a short time dt, you just observe how much the speed increases by, that I am calling it as dv. So that dv by dt is the acceleration. Okay, that dv by dt is the acceleration. So yeah, that is the main idea. Now for constant acceleration, if we have constant acceleration, this idea is also important. Let's say the block starts from rest and the acceleration is to the right, and let's say it is 10 meters per second square. Okay, then what will this motion look like? That is an important, what will happen to the speed here is important. So this is at the start, this is after 1 second, and let's say this is after 2 seconds. So at the start, it is of course at rest. Now 10 meters per second square acceleration, it means the velocity increases by 10 meters per second every 1 second. Okay, like if you split that second square into in this manner, you can read the acceleration as 10 meters per second every second, right? So the speed will increase 10 meters per second each second. So this is at the start, t equal to 0. So after 1 second, the speed will be 10 meters per second. After one more second, after one more additional second has passed, the speed will be 20, 10 plus 10. Okay, at 3 seconds it will be 30 and so on. So the acceleration increases, velocity increases 10 meters per second every second. That is what it means physically. Okay, and this is something, this is only true for a constant acceleration. If acceleration is constant or uniform acceleration, then this is true. Okay. All right. Now, so there is also average acceleration as well. This is also an important formula. So what does average acceleration mean? So we discussed three types so we discussed average velocity, right? Average velocity was delta r vector by delta t, change displacement by time, and average acceleration will be delta v by delta t, change in velocity vector in that time duration. Okay, so in some journey, okay, let's say the initial velocity vector at the start was vi, okay, and finally the velocity vector became vf at time t equal to delta t. Then the average velocity, average acceleration is defined as the change in velocity vector, which is v final minus v initial divided by the time duration. Okay, change in velocity vector divided by the time. So to take an example, take one dimensional motion again. Take one dimensional motion again. So at the start, velocity vector is 10 meters per second along the x direction, and after, let's say, 50 seconds, the velocity vector becomes 50 meters per second. So this is the velocity at 0 seconds. This is the velocity at 50 seconds. So everything you have to substitute as vectors. Okay, so average acceleration, everything you have to substitute as vectors, is the final velocity, which is 50 I cap. Okay, so you have to include the I cap because you have to substitute velocity vector here, minus initial velocity vector, which is 10 I cap, divided by the time duration of this journey, which is 50 seconds. So this is going to be 40 by 50, which is 4 by 5. 4 by 5 I cap meters per second square, or 0.8 I cap meters per second square. Okay, so this is the average acceleration vector. If you want the magnitude, only take the 0.8. Okay, we will only take the 0.8. Okay, great. Now let's also take the 2D example. The 2D example is this is the x, this is the y, something like this. So this is the path of the particle. Okay, at the start the speed was along the x direction, it was moving in the x direction, and the initial speed was 10 meters per second, and finally after, let's say, 10 seconds, it is over here and its velocity is now along the y direction. Okay, velocity is along the y direction equal to 10 meters per second itself. It is along the y direction, and this journey happened in 10 seconds. This journey happened in 10 seconds. So here, tell me guys, what is the average acceleration? What is the average acceleration in this journey? Okay, you guys tell me, try this out. No, Arjun, it is not possible without vectors, because the definition itself is a vector, right? Average velocity is change in velocity vector, delta v vector. Okay, and velocity is a vector, so you have to substitute the vector, otherwise you will get the wrong answer. Okay, so finally the velocity is in the y direction. After the 10-second time, velocity is in the y direction. Anybody got the answer? Anybody? So here, what is the final velocity vector? This 10 meter per second along the j cap, right? So v final is 10 meters per second in the j cap, so it's a 10j velocity, right? And initial velocity is 10I. So initial velocity is 10I. What is the time duration? 10 seconds. Average acceleration is change in velocity vector divided by the time duration. So final velocity vector is 10j, initial velocity vector is 10I, divide that with the time. Okay, so this will be j cap minus I cap in meters per second square. Okay, 1 j cap minus 1 I cap, right? So if you want the magnitude, what will that be? If you want the magnitude of average acceleration, what is the magnitude of j cap minus I cap? Root of x component square plus y component square. So it will be root 2 meters per second square. This will be the magnitude. Okay, this will be the magnitude. Okay, so that is how you find the average acceleration. Great. Now we have this question. Particle is moving in a circular path. Okay, radius 8 meters, uniform speed of 4 meters per second, and you have to find the magnitude. So here, as you can see, they have mentioned the magnitude of the average acceleration. Okay, when particle completes 1/4 of the motion. So we have a circle and some particle over here and over here. Okay, So what does 1/4 of the journey means? It starts from here and let's say it ends here. So in this journey, they're asking the magnitude of average acceleration. So for average acceleration, we need final velocity vector and initial velocity vector, and then divide it with the time duration, right? So initial velocity vector, uniform speed. So speed is constant. Speed is always 4 meters per second in this circle. So at the start, the velocity vector is in this direction. Velocity vector is always along the tangent. So this dot, this particle is moving in the upward direction at the start, like this. This is the initial velocity. Okay. And final velocity, when the particle is here, its velocity will be to the right, sorry, to the left. It will be having a velocity like this. Speed is the same at both points, 4 meters per second. Okay. So what is the initial speed? 4 upwards, right? So that I can write it as 4j cap, right? The up direction I can consider that as j. So initial speed I can write it as 4j cap. Finally, it is 4 to the left. Okay, and 4 to the left I can write it as 4 in the minus I cap, which is minus 4i. This is final velocity, this is initial velocity. Now just put everything into this formula. So final velocity is minus 4i, okay, minus initial velocity is 4j, divide that with the time duration. Okay, so for time duration, what we'll do is, so what is the distance covered? Okay, time we will calculate. I'm writing it as delta t for now. So this will be minus 4. If you take minus 4 common, it will be I plus j divided by delta t, right? Now, how do you find the time to go from here to here? We'll do distance by speed, right? This is a constant speed motion. Distance covered is pi r by 2. This distance covered is pi r by 2, right? Length of the quarter circle. So time, if you want, time to go from A to B is the distance, which is pi r by 2. Radius is 8 meters, right? So pi into radius by 2, this is the distance, divide it with the speed. Speed is 4. So this will be pi seconds. So it takes pi seconds to go from A to B. Okay, so delta t is pi. So the answer will be minus 4 divided by pi I cap plus j cap. This is the average acceleration vector. Okay, if you need the magnitude, then use the vector magnitude formula. The magnitude of the average acceleration. So there is a constant of 4 by pi, so take it outside, and then inside we have I cap plus j cap, right? So that will be root 1 square plus 1 square, root of x component square plus 1 y component square. So this will be 4 root 2 divided by pi meters per second square. This is the magnitude of average acceleration. Okay, so this is what the solution is. Okay, this is the solution. Okay, class duration, I told you, right? It will be till 9 o'clock. So is this clear, guys? 4 root 2 by pi. Okay. Then, yeah, so instantaneous acceleration, we discussed it. All you have to do is differentiate velocity. Differentiate velocity with time. Then you get the acceleration, instantaneous acceleration. If you differentiate the position with time, the x with time, this gives you the velocity. Okay, and then once again, if you differentiate the velocity, you get the acceleration. Okay, so we can do a question on this. Here velocity vector is given and they're asking the acceleration at 2 seconds, 2-second time. So just differentiate it. So velocity is given, so acceleration will be, so 2t square, so the 2 comes front, 2 into 2 is 4, so 4t. Okay, and here we have a minus 4t, differentiation of t will be 1, so what is left is minus 4. Differentiation of a constant is 0, so this will be the acceleration in meters per second square. So as you can see, this is not a constant acceleration. The acceleration also changes with time. Now, what is the acceleration at 2 seconds? At 2 seconds, so we just write it like this, acceleration at t equal to 2 seconds, or you can also write it this way, acceleration at 2-second time. So just put instead of t 2, so 4 into 2 minus 4, 8 minus 4 is 4 meters per second square. Okay, so this will be the acceleration at 2 seconds. Yes, 4 will be the answer. 4 is the answer. Okay. All right. Okay. Then what is the next one? Yeah, so this is a NEET question, NEET PYQ 2024. So here they're asking, they have given the value of x, okay, where the particle is at a time t that they have given. They're asking what is the ratio of the initial velocity, which is the velocity at the start, to the initial acceleration. Okay, to the initial acceleration. That is what they're asking. Okay. So give it a try. Give it a try. Yes. So here we have we have position, right? The x coordinate. So if you want the speed will be dx by dt. Okay. So now you just need to know how to differentiate this. Okay. T raised to 4, its derivative will be 4t cube, right? So alpha into 4t cube, that will be 4 alpha t cube. Derivative of t square is 2t. So that will be 2 beta t, the second term. And derivative of the third term, t will be 1. So the third term will be simply gamma. Okay, that is the third term. This is the velocity. Now, initial velocity is what is being asked. That is velocity at 0 seconds, right? This is the initial velocity. So, if you put t equal to 0, you get gamma. Okay, gamma is what you get. This is initial velocity. Now, for acceleration, we'll differentiate it once more. We'll differentiate velocity. So, t cube's derivative is 3t square. So, 4 3s are 12. So, 12 alpha t square. T's derivative is 1. So, plus 2 beta. Okay, this is the acceleration. Initial acceleration means acceleration at t equal to 0. Okay, that is 2 beta. So, they want this divided by this, which is gamma divided by 2 beta. So, the ratio is gamma is to 2 beta, D option. Okay, D option will be the answer. All right. Yes, D will be the answer. Okay, so yeah, so here you had to use pure calculus. Just know, if you know how to differentiate, then this is easy. Okay. All right. Next one. Yeah, so now we can discuss the equations of motion. Okay, these equations you guys have already studied in 9th standard. Okay, so we can just quickly derive them using calculus itself, derivation, differentiation and integration. So we start from, okay, so first important condition is these, ignore the vector part, these three equations, right? V equal to u plus at, s equals ut plus half at square, and this third one, this is only applicable, only, these are only applicable for constant acceleration motion. Okay, for constant accelerated motion. Okay, that means the acceleration needs to remain a constant. Okay, only then you can use these equations. So now if I write the acceleration as dv by dt, rate of change of speed or velocity, this acceleration is a constant. Okay, that is what we are starting with. The acceleration is constant for this motion. So now we will rearrange this equation. We will write dv as a dt, acceleration into dt, take the dt and send it to the other side, and now we integrate. Okay, so here I am using integration as well. So now the thing is, for integration you have to write down the limits. So t equal to 0 at the start, what is the velocity? So I am giving that a symbol of u. U is the initial velocity. U is the initial velocity. Okay, at t equal to 0 the velocity is u, and at some time t I am saying the velocity is v. So integral dv will simply be v. Okay, so if you put the limits, it will be v minus u, upper limit minus lower limit. So the left hand side will be v minus u, and the right hand side, because a is constant, you can take it out of the integration. Integral dt will be simply t. So right hand side will be a into t. Okay, this gives us the first equation, which is v equal to u plus at. Okay, we'll understand how to use these equations in a bit. This is the first equation. Okay, v equal to u plus at. Now, now the next thing is the displacement equation. So we will continue with the velocity equation. We will continue with the velocity equation. And velocity we will write it as dx by dt dx by dt. Now take dt to the other side. So dx, you can write it as u dt plus at dt, right? Now integrate once again. Now we will integrate once again. U is a constant, a is a constant, right? Now integration of dx will be delta x, okay, which is also called the displacement. Integral dt is t, so this will become ut. Integral t dt, integration of t dt is t square by 2, t square by 2. Okay, I'll write the general formula here. General formula is t raised to n plus 1 divided by n plus 1. Okay, if you are integrating t raised to n, this is the general formula. Okay, so integration t dt will be t square by 2. So a t square by 2. And this is the second equation. Displacement, you can write it as ut plus half at square. This is the second important equation. Okay. Then speed is slow. Okay, then I can speed up a little bit. Okay, so now so this I will give you as hint. Okay, for the third equation, v square equal to u square plus 2as, what you can do is, from the first and second equation, okay, this you guys do as homework, eliminate time. Okay, eliminate time. Okay, so eliminate t. So basically in these two equations you can see a t, right, t variable. So you can take time as v minus u by a from this and put it into this equation. That then you will have to solve some equation and you will get this relation. Okay, you will get the third relation. Okay. Yes, now we can continue then. Okay, so now we'll discuss how to apply those three equations. So I'll speed up a little bit, right, because it's already 8:30. So velocity of a moving body is 2 meters per second square. Velocity of a body moving with a uniform acceleration. So whenever you see uniform acceleration, only then use those equations, right? Is 10 meter per second. What happens to the velocity after 4 seconds? Okay, so just apply that equation. So there are a few rules you need to keep in mind when applying these equations. Okay, first thing is, if let's say the motion is happening in the x direction, you have to choose one direction as positive. Okay, so say we choose the right direction as the positive direction. You have to either choose the right as positive or the left as positive. Okay, now so here let's say the body, its initial speed is 10 meters per second. I am saying to the right, and acceleration is 2 meters per second square, right? So if you choose the right direction as the positive direction, any vector to the right, okay, and by vector I mean velocity, acceleration and displacement, right? Of these three, any vector that is along the right, you will take it as positive, and anything that is to the left, you will write it as negative. Now we need velocity after 4 seconds, right? Velocity after 4 second time. So we'll use v equal to u plus at. Okay, v equal to u plus at. Now initial velocity is 10 meters per second to the right, and right is positive. So I'll substitute that as plus 10. Okay. Now acceleration vector is also along the right, so I will write it as 2 plus 2, and time is 4 seconds. Okay, so the answer is 18 meters per second. Okay, C option. Yes, 18 is the answer. Now the next one is, there are two cars, starter rates with initial velocity of 2 and 4. They travel in a straight line with uniform acceleration. Okay, so there are two cars that start their motion. Their initial speeds are different. Okay, one guy has a speed of 2 meters per second. The other particle has 4 meter per second speed. Their accelerations are 2 and 1 respectively. So this guy's acceleration is 2 meters per second square. This guy's acceleration is 1 meter per second square. If they reach the finish line at the same time, okay, so this person and the second person, they both reach simultaneously at the same time. Both reach the finish line at the same time. Then the question is, what is the length of this race track? So what is this length? Okay, the length is the question. Okay. All right. So let's begin. So here the thing is, we know the displacement. The displacement is L. Okay. We know acceleration and initial velocity. So of course we will use the second equation, right? Displacement equal to initial velocity is 2 into t. Let's say it reaches the finish line at after t seconds, plus half into acceleration into t square. This is the first guy's equation. Now for the second guy it will be 4t plus half acceleration into t square. So now what can we do? We can subtract these two, right? Right, we need the time, right? So we don't need the time, we need the length. Okay, so basically so this is going to be t square, right? This is t square by 2. So I'm going to multiply this equation with 2. So it will become 2L equal to 8t plus t square. Okay, and the first equation was L is equal to 2t plus t square. Okay, now just subtract these two. So left side becomes L and the right side becomes 4t. Okay, right side becomes, sorry, 6t. If you divide it, it will become 6t. So from here you can get the time, right? The time you can get, it is L by 6. Relation between t and L you can get. And now you just have to put this into one of these equations. Wait a second. 2L is equal to 8t plus t square. That is correct. Then for the first one that is also correct. So yeah, so seems correct. Now so now just put it into one of these equations. Okay, just put it in the second equation. So L is equal to 2 into t is L by 6 plus t square, which is L square by 36, right? So cancel out 1L. So 1 minus 1 by 3 is 2 by 3. So this cancels out 12 times. So L is 24. Okay, after that it's just solving. But the main equation is these two. These two are the main equations. Okay. 24, yes, most of you wrote it. 24 is the answer. Then we have this question. Car is moving along a straight road with uniform acceleration. It passes through 2 points P and Q separated by a certain distance with 30 and 40. What is the speed at the midpoint? Okay. So we have 2 points P and Q. Acceleration is still uniform only. Here the speed is 30 kmph. Here the speed is 40 kmph. They're asking velocity at the midpoint, speed at the midpoint. This distance is unknown, right? So I am taking both these distances as dd, okay? D and D. So what is the relation between speed, displacement and acceleration? It's the third equation, right? So I'll apply v square equal to u square plus 2as. Okay, so first I'll apply it between the first 2 points, okay? This point P and this middle point. So it will be v square minus u square equal to 2 into acceleration into displacement is d, right? From here to here the displacement is d. And then I'll apply from the starting till the final point. So if I do that, it will be 40 square minus 30 square is equal to 2 into A into displacement. Displacement now it's 2D. It's going to be 2D. Okay. So 2AD is this. So this is nothing but 2 into 2AD, right? 2 into 2AD. 2AD I can write it as V square minus 30 square. That's all. Now we just have to solve this. So 2V square equal to 40 square on the left side, and I guess it will become 30 plus 30 square. So V square is going to be 30 square plus 40 square divided by 2. Okay. What is 30 square plus 40 square? Pythagoras. It will become 50 square divided by 2. Now take the square root. So it will be 50 divided by root 2. 50 divided by root 2. Okay. 50 divided by root 2, and 50 by root 2 you can make it look like A option. Multiply and divide with root 2, so it will become 25 root 2. Okay. So this is this you can also remember as a result if you want. The speed at the midpoint. So if the starting speed is u, if the ending speed is v, then the speed at the midpoint is root of u square plus v square. Hold on. The root is in the whole thing. U square plus v square divided by 2. Okay, that is the result. Root of 30 square plus 40 square divided by 2. Okay. Yes, 25 root 2 is the answer. Okay. Then so distance in the nth second. Yeah, let's just do motion under gravity here. Okay. Let's do motion under gravity. So motion under gravity is basically so we learned the constant acceleration equations, right? The 3 equations of motion. So they were all for constant acceleration. Motion under gravity. So the motion will now be along the y direction. And let's say this is the ground. So motion under gravity, here we'll be discussing problems like dropping a ball and stuff. Okay. So if you drop the ball, the acceleration with which the ball falls to the ground, that is known as acceleration due to gravity. Okay, and we give it the symbol of g, acceleration due to Earth's gravity. Okay. Okay, and this value is roughly 9.81. Okay, 9.8 meters per second square. And sometimes for solving questions, we take the value of 10 also. Okay. So everything else is the same. It's our three equations itself. So V equal to U plus AT. Instead of AT, it will become GT. And the displacement equation becomes UT plus half GT square. And the third one becomes V square equal to U square plus 2GS. Okay. And this is a y direction motion. So you need to understand that also. Other than that, everything is the same. Okay. There is no difference from the previous questions we did. So now there are a few results here: maximum height and time of flight. Okay. Situation is we are throwing a ball upwards with a speed u, and we are looking at the motion, right? So this ball will go up, okay, come to rest at a point, at the topmost point, and then it will come down, reach the ground after some more time, right? So we are trying to find the time it takes to go and come back, and this maximum height from the ground. Okay. So for finding the time, what we'll do is we'll write the displacement equation. So displacement equation will be y equal to, because the motion is happening in the y direction, right, ut. So here the thing is, I am choosing the upward direction as positive, right? You have to choose one direction as the positive direction. So I'm choosing the upward direction as positive. So any vector that is in the downward direction will be negative automatically. So u is upwards, so I wrote it as positive. G is actually downwards, right? G is always towards the ground. So G we will substitute with negative, right? So minus half GT square. Now the thing is, when it goes up and comes back, y direction displacement is 0, right? So it moves up and comes back at the same point. So y direction displacement is 0. So if I do that, and that time of flight I am calling it as capital T, this is the condition I get. Now cancel out 1t, and the time of flight you get is 2u by g. Okay, 2u by g. So if you project a ball upwards with u meters per second, it comes back to your hand after 2u by g time. Okay, it comes back after 2u by g time. Now this is also this is a symmetric motion, so that of this 2u by g time, the time taken to go reach the maximum height will be u by g, half of it, and the time to go from the top back to the bottom, this will also be u by g. So in total it will be 2u by g. Okay. So now we just need to find what is this maximum height. For that, notice that this maximum height is the displacement along the y direction at time u by g. Okay, at the time u by g. So in this equation, instead of the time, if I substitute u by g, the y will be maximum height, right? So maximum height is u into u by g, u into u by g minus half g into u by g the whole square. So this will be u square by 2g. There is also another way to derive the same relation. You can use v square equal to u square plus 2as. Okay, and here it will be minus 2gs, 2g by. And here at the topmost point, you can put the speed equal to 0, right? At maximum height, speed will be 0. And from here also you will get the same result, u square by 2g. U square by 2g is going to be the maximum height. Okay. All right. So these two formulas, guys, they're important. Okay, if you project a ball up with the speed u, it comes back to you after 2u by g time, and the maximum height from the ground it approaches, it goes is u square by 2g. Okay, then we have this question. Okay, and here a ball is projected upward with a speed of 50 meters per second. First question is, what is the maximum height? So maximum height, just use that direct result. It will be u square by 2g. Okay, so what will this be? 2500. So just take g as 10 for calculation simplicity. So this will be 125 meters. Okay, so it goes up by 125 meters. Then what is the time to reach maximum height, not time of flight? So that time is u by g, right? It will be u by g. 50 by 10 is 5 seconds. Then speed at half the maximum height. Okay, this is something else. So ground, this is the maximum height point, let's say. This is the maximum height point. They're asking middle, the midway point. At this midway point of h by 2, what is the speed? That is what they're asking. So here we will use v square equal to u square plus 2g, sorry, not 2 plus, it will become minus 2g into h by 2, right? Now what is h? U square by, it's actually 125 meters, right? We calculated it. So this will be 125 divided by 2, right? That will be h by 2. So u square will be 2500 and 2 cancel. This will become 1250, right? Now this is 1250. So v will be 25 root 2, right? 1250 is 625 into 2. So 625, take it outside, the square root. So it will be 25 root 2. This is the velocity midway at a height of h by 2. Then C is also done. D is the time of flight. Time of flight will be double this time, right? So 10 seconds. This is just 10 seconds. Velocity after 1 second and 6 seconds. Okay. So what is going to be velocity after 1 second and 6 seconds? So here you can use the v equal to u plus at relation. So velocity equal to initial velocity is 50 minus g into t, right? 1 second. So this is 40 meters per second, and velocity after 6 seconds, it will be 50 minus g into 6. This comes out to be minus 10 meters per second. Okay. Now minus means it is downwards. So here the velocity vector is 10 meters per second downwards. Positive means it is upwards. Okay. That's all. Then finally, the height from the ground at 1 second and 6 seconds. So this you guys can try it yourself. So height, use the displacement formula, ut minus half gt square. Okay, just put t equal to 1 and t equal to 6 into this, and you will get the answers. Okay, you will get the answers that way. All right. Okay. Then this question, you guys, I'll give you some homework. Okay. This question also we can do. So here they are saying a ball is thrown vertically downward with a velocity of 20 meter per second from the top of a tower. So there is a tower, there is a ground. From the top of a tower, a body is thrown with 20 meter per second downward. So from this point, a ball was thrown with a speed of 20 meters per second downward. Okay, it hits the ground with a velocity of 80. So the moment it reaches the ground, it is hitting it with a speed of 80. Then they're asking what is the height of the tower. Okay, height of the tower. So the displacement of the ball is actually the height of the tower itself, right? I know initial speed and final speed. G is also downward. So all the four vectors are downward, right? So everything is positive. I'll just choose the downward direction as positive. So V square equal to U square plus 2 into G into height of the tower. This will give you the answer, right? So 20H will be 80 square minus 20 square. So use A square minus B square. So it will be A plus B, which is 100 into A minus B, which is 60. So 20 and 60 cancel 3 times. So height of the tower will be 300 meters. 300 meters. Okay. So just the V square equal to U square plus 2AS. All right. Okay, okay. अभी end कर दो. Okay. Okay, guys. So we are going to end the lecture. Okay. So I'll let me see if I have some homework for you. Okay. So you'll get this PDF after the lecture. So this question you guys can do it as homework. And yeah, I mean, other than that, we had the graph part. Graph we can do it in the next lecture. Okay. They'll also bring math, that basic math part. Okay, other than that, any other doubts you guys have? any other doubt other than that? Okay. Any other doubts? Yes, so the class is about to end. Okay guys, good night, take care. Okay, so in the next lecture I'll take up basic mathematics, and we'll also do the graph questions. Okay. Okay guys, goodbye.